Right, so this is the triangle A, and there are a number of transformations. See this triangle here? This is, see my ruler? That's the y-axis. So this is the transformation through the y-axis. So let's say if I was standing here, at this point I am 2 centimeters away from the mirror, 1, 2, and if I look in the mirror, my image will be 2 centimeters to the far side. Alright? This one here, I'm 4 steps away from the mirror, so my image will be 4 steps away. This point here, I'm 1 step away from the mirror, and my image will be 1 step away. Alright? So that's the image in axial, it's axial symmetry in the y-axis. So axial symmetry in the y-axis means the mirror is placed on the y-axis. Axial symmetry in the x-axis. So let's say start with A again. See this point here? This is my mirror now. Axial symmetry in the x-axis, this is my mirror. And I am, let's say if I was standing here, I am 1 step away from the mirror. So my image is 1 step away on the far side. This point here is 3 steps away from the mirror. So 3 steps away. This one is 5 steps away from the mirror, so it's 5 steps the other side. So that's axial symmetry in the x-axis. The mirror is placed on the x-axis. The other type of symmetry is point symmetry, or central symmetry, where the mirror is, do you ever see those, do you know when you're pulling out of a parking space and you can see the mirror on the wall? Do you know one of those circular mirrors? Right. Right, so this is the mirror here, this point alone. Forget about these 2 triangles. So if I was standing here, I am that distance away from the mirror and the same distance the far side. So this is the mirror, this circular thing. This point here is that distance away from the mirror. So you use a ruler, measure it, and the same distance the far side. You go the same distance the far side. This point up here is measured with a ruler to the center, is that distance to the center and the same distance to the far side to get that point. So this is called central symmetry. Center, because that's the center of the graph. Right. So the first question, write down the coordinates of the images of the vertices of A on the transformations listed below. Alright. So what we have to do is axial symmetry in the y-axis. Which way do I put my ruler?
The other way.
Down the ways, yeah. So I am, this is me, this is the A. Now where is my image? It's over here, isn't it?
Yeah.
So basically what we have to do is write down all of those coordinates. What's the first coordinate here? That is 1, 1. It's 1 coordinate. Write out this coordinate here. See that coordinate?
2, 5.
2, 5. And this coordinate here is
4, 3.
4, 3. That's all you have to do. Same for the next one. Central symmetry in the point 0, 0. So this was the last one that we did. So central symmetry means that we have to pick all this triangle and these points. So what's the first point here? So it's 1, always the x coordinates first. 1 minus 1. This one down here is 2.
2 minus 5.
Raymond, what's this one?
4 minus 3.
Well done. Alright, so this is the last triangle. So it's an axial symmetry in the x-axis. So here's my original triangle and here's my image. So it is this one. It's this one. Alright, so Jalsa, what's this coordinates of this point? X-axis. Minus 1, minus 1. Try the next one. This one here. Minus 4. See that? Minus 4, minus 3. Try and get the next one.
-2 -2.
That's it. -2, -5. That's all you had to do there. Now, question 12. Did everybody get a chance to try this yet?
Yes.
Did? Right, plot the points. -2, -2. So, -2, x-axis first. -2, -2. And that is the point A. The next one, you have to write the letters beside them when you do it. B is 6 -2. 6 -2. And C is 7 3. 7 3. That's C. Construct the point D such that A, B, C, D is a parallelogram, and write down the coordinates of D. So we'll go. So what we do first of all is we follow the letters. We start with A. It says A, B, C, D. So we start with A and we connect A to B. Then we connect B to C. And it's a parallelogram, so this line is going to be parallel. So one way we can do it is we can count the number of squares along here and count the number of squares back, same distance. So we can count the number of squares: 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16. Do the same here. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16. There you go. That's one way of doing it. Right? Or what you can do is from B you can count over 2 and up how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do the same at A. You can go over 2, 1, 2 and up 10. And you land here. So that's it. That's D.
Why do you go over 2?
You can. There's two ways of getting there. So how do you get from B to C? You go over 2 and up up 10. So to get from A to D, you go over 2 and up 10. Alright, so D coordinate is, what is it? -1, 3. In question 9, on page 9, you identified some properties of parallelogram. Write down one of these. So what's a property of parallelogram? What can you tell me about these two lines here? They are both?
Parallel.
Yeah. So opposite sides? Parallel. Are opposite sides equal in length? Are they equal in length?
Yes.
Yeah. Equal in length. And something else about a parallelogram. The diagonals bisect each other, don't they? So the diagonals cut each other in half. See? That's the same distance as that. That's the same distance as that there. So diagonals bisect each other. And D, using coordinate geometry formula, verify that ABCD has the properties you wrote down. Alright, so using coordinate geometry, what we can do is we can find the length of AD, and that should, AD should be the same length as BC. That's one property. Opposite sides are equal in length, so we'll prove that property. So that line is equal in length to that line. Alright? So the coordinates of A. So we'll find the length of AD first. So we'll write down the 2 points A and D. So A -2, -2, and D is -1, 3. So that's 1/2 the sum, and then we'll find the length of BC. So B is 6 minus 2, and then C is 7, 3. First thing you do is mark them, both of them, x1, y1, x2, y2. x1, y1, x2, y2. And if you've done that, already you've passed the question. Right, so the length of the line AD, that's how you write it. The length of the line AD. We'll write down the length of the line formula. x2 minus x1 squared plus y2 minus y1 squared. And over here we'll get the length of the line BC. x2 minus x1 squared plus y2 minus y1 squared. Alright, can everybody see clearly? We'll zoom in a bit so you can see. Alright, so we'll fill it in. Alright, so shout it out there, Oshin. We'll follow the formula as we go along. First of all, x2 is and the next sign is a minus. Write it down. x1 is, so write down minus 2. Like that. Plus bracket y2. Formula says it's minus next. And y1. Now, just for quickness sake, what's a minus times a minus? See this bit here?
Plus.
So what I'll do is take the two minuses and I'll make a plus out of it. A minus times a minus here also plus. So
Is
that
that minus 3?
there's no minus 3, no. Right, so we have to figure out, we have to add minus 1 plus 2. If you're not good at that, use a calculator. So it's the same as 2 minus 1, which is 1 squared. And 3 plus 2 is 5 squared. We'll finish it off. AD is equal to the square root sign. 1 squared is 1 times 1 is 1, and 5 times 5 is 25. So AD is equal to square root 26. Now you can leave it like that for the moment, and let's see how the other side works out. Alright, so on this side, Kevin, x2, follow the formula over here. x2,
7.
7. Minus, next, and x1.
x1 is 6.
x1 is 6. Bracket squared. Plus y2.
3.
And then there's a minus. And y1.
Minus 2.
See the way I'm following the formula? That's what you have to do. Alright, so we'll do 7 minus 6 in the bracket is 1. And the bracket on the right, that's a minus times a minus gives you a plus. 3 plus 2 is 5. So BC is equal to 1 squared is 1 times 1 is 1, and 5 squared is 5 times 5 is 25. BC is equal to square root 26. Now both sides are equal in length. So AD is equal in length to BC.